So some of you may know that our center, the Water Resources Center, is part of a larger body called the National Institutes for Water Resources, or NIWAR. NIWAR is made up of a network of centers and institutes like us. There's one in every state, plus the District of Columbia, Puerto Rico, the U.S. Virgin Islands, and Guam, so 54 of us altogether. Well, each center focuses on the water issues in their own state. It's also true, of course, that many water issues occur in multiple states. So there's an opportunity for us to work together on larger topics that have national significance. The glue that really holds this whole network together and creates the opportunities to work together is the fact that we all receive some base funding through a program at the U.S. Geological Survey. And that program, in fact, creates this unique kind of partnership between the USGS as a federal agency and all the state institutes. I mentioned before that the Water Resources Center created its own strategic plan that was finished within the last few months about our own future directions. And as it happens, a similar sort of exercise is happening at the national level with NIWAR and within the water mission area at USGS, of which the State Institutes program is a part. So to discuss these national priorities at USGS and where the State Institutes fit into that, we're very pleased to have with us Dr. Earl Greene, who's the director of the State Water Resources Research Institute's program at USGS. The next thing I get to tell you about Earl makes me very happy. He's a graduate of the University of Minnesota. He did his graduate work at the University of Idaho and then began his federal career with the research branch of the U.S. Forest Service in 1983, moving to the U.S. Geological Survey as a research hydrologist in 1986. His research is focused on modeling flow and transport of water in karst and fractured rock terrain. As director of the State Water Resources Research Act program, he establishes total programmatic direction, reports on activities of the institutes, coordinates and facilitates regional research and information, technology transfer, and operates the USGS Student Intern Program. Please join me in welcoming Earl Greene.
Well, hello, good afternoon. This is a lot of fun to be here since I'm a graduate of the university. Grew up here in Minneapolis, spent my summers sailing Lake Minnetonka every day that I could, my winters skiing Buck Hill every day after school, and that's how I live my life 40 years later. I live on a sailboat, and I spend 60 days a year skiing, so I haven't changed, so it's great to be back. I'm going to start out with a story. In the beginning, there was a plan, and then came the assumptions, and the assumptions were without form, and that plan was without substance, and darkness was upon the face of the workers. They spoke to themselves, saying, "This is a crock of poo, and it stinks." And the workers went to their supervisors and said, "It is a pail of dung, and we can't live with this smell." Supervisors went to the managers, saying, "It is a containment of excrement. It is very strong, and none may abide by it." And the managers went to their directors, saying, "It is a vessel of fertilizer, and none may abide its strength." The directors spoke among themselves, saying to one another, "It contains, which aids plant growth, and is very, very strong." And the directors went to the vice presidents of the organization, saying to them, "It promotes growth and is very powerful." And the vice president went to the president and said to him, "This new plan will actively promote the growth and vigor of the company with very powerful effects." The president looked upon the plan and said, "This is good." And the plan then became policy. And my friends, that's how shit happens. So I'm going to talk about plans. Maybe I should have started with something different, but I'm going to talk about plans at the U.S. Geological Survey. I want to take you So I've sat through a lot of talks this morning, really nice, great site-specific talks, things happening in Minnesota to help managing the managers, the consultants, the university researchers here to really look at site-specific areas, problems that are happening in the state. That's really what we do with the Water Resources Research Center program. But I want to take you a little bit higher. I want to talk about at a higher level of what's going on at the national level. And so that's really what I want to spend a few minutes doing that, take some questions, and then give you some free time to do some networking. So that's really all I want to do while I'm here at lunch, and I really thank you for being here and giving me part of your time. So I want to start out with the U.S. Geological Survey, my agency for many years. We have 7 mission areas. We have what we call the core science systems, which is our area where we really is our mapping efforts. This is where we do topographic mapping, geologic mapping, hydrographic mapping, that kind of thing. That's where Landsat resides for our Landsat work. And so that's really one of our big core mission areas to really map as an earth science agency. And then many of you know we have an ecosystems group that looks at sustainable management and conservation of our biological resources. So that's another big group. We have, of course, our energy and minerals group where we map the minerals for the nation. We map our oil and gas reserves. And so that's another branch of the USGS where we do a lot of that kind of work. We have an environmental health group that provides the science to transport effects of contaminants on human health. Another big area, we have our natural hazards group that really assesses and conducts research on floods, earthquakes, volcanoes. They've been in the news a lot lately. And so that's and last but not least, we have our water resources group. And that's what I'm in, and that's what my program is part of that group. And we are the biggest group within the U.S. Geological Survey. We're about $500 million when it comes to doing research and studies across the nation. Our job is to monitor, assess, and conduct research that will deliver information on water resources, including, as you all know, stream flow, groundwater, water quality, availability, water use. We do our mandate by Congress is to do all of that kind of work. And to do that, we have 4 programs within the U.S. Geological Survey. We have what we call a water availability and use program, and it does what the name is. It provides an assessment and the status of our water resources of the United States across the nation. That's what that group does. We determine the quantity and quality of water that's available for lots of different uses, whether that's for water, drinking, agriculture, and so that's really our mission. We identify long-term trends in water availability through groundwater models. It's a basis for any kind of our approved ability to forecast water for economic purposes, energy production, and any kind of environmental uses. So that program is a big program. We have offices, and about 29 offices nationwide. In many states, we've since combined some. But that program really does a lot of work with water use within the states. It does a lot of work on groundwater modeling, assessments of groundwater systems, surface water for drinking water, and availability. So that's a big program. Another program you're very familiar with, or many of you have already heard the name many times, is our National Water Quality Program. That mandate of that program is to provide an understanding of water quality conditions across the nation. That program tries to determine trends in water quality. Is the nation, essentially, it asks and tries to answer a very simple question, though it's hard to do. Is the water quality of our nation getting better, or is it getting worse over time? And so that's really the core of that program. We work on how human activities are affecting water quality, how natural changes are affecting water quality, and so that's that program that really tackles that. It really tries to serve society and you all with collecting the data. And the cool thing about the U.S. Geological Survey and our programs is since we're federal, we can do long-term data collection and long-term research. And that really is what sold me on coming to the U.S. Geological Survey. We're not like a university. We don't have to do 3-year studies, 1-year studies. We can sit and study a problem for decades if it's needed to come to a solution or an answer. And that's the exciting part. And that's why our NAWA program has been in business for over 30 years, still trying to answer that basic question. We're learning things as we go, and that is our mission with the USGS. And so we're trying to look at the condition of the nation's streams, rivers, and groundwater through the NAWA program, look at how those conditions are changing over time, how human activities are affecting those conditions, and how water quality changes will occur in the future. Try to predict those before they even happen, and that's some of our new mission areas. And we have another program that many of you also use, I hope. And if you don't, come see me afterwards, and we'll talk about how you get there. And that's our groundwater and stream information program, right? That's our gauging program, where we're gauging streams for data, so that you can use both stream quantity and quality. And hopefully everybody is using that, going on to the USGS websites. It's all public domain, downloading and using data. If you don't know how to get there, get a hold of me through Jeff, Joel, the Institute, anybody, and I'll get you set up, because that data is for you to use in all of your studies. And we maintain several thousand stream gauges across the nation and thousands of wells. We're collecting water level data, water quality data, both in groundwater, surface water, collecting stream data. And that is really, that kind of information is what you may need for flood planning, any kind of flood planning, warning, stream flow forecasting, if you're working in that area, looking at water supply, water quality management for municipalities, watersheds, counties. If you're doing that kind of work, if you're looking at water infrastructure design, building culverts, building bridges, all that data is there for you to use and to use that. And so I really hope folks are using that kind of data. So what I want to do is take a couple of minutes before I get into the last program, which is our program, the Water Resources Research Institute program. I want to talk about what is a couple of new science initiatives that we think at the national level that we're starting to move into. And I want to share those with you because I think they're pretty interesting. These are things that we're trying to develop and work on for the future, and hopefully some of this will resonate with you, and hopefully some of this will help you in your work. So one of the new areas we're trying to work in, that we're starting to develop, standing up research teams, is on integrated model development. For my career, we've been, essentially one-up models. That's how I learned. It's a groundwater model, it's a surface water model, it's a water quality model. They served our purposes. They were one-discipline models. What we're trying to do now is to build what we call integrated multidisciplinary models, tools to understand and predict water availability, water quality, ecosystems health, all within one modeling platform. Trying to tie those kind of models together to really answer those kinds of questions. Obviously, these are really be difficult tools to develop and models, because they have to be able to integrate atmospheric, hydrologic, hydrodynamic, biological, geochemical processes, all in a changing climate with hydrology, land use, anthropogenic chemical loadings. All that has to be pulled into those models. So this is a grand challenge for us, is to develop these kind of modeling platforms and tools for you all to use. I'm excited by that, because I think it'll generate a whole new area of research scientists. Scientists are going to have to understand something about all those disciplines. And so that's pretty exciting, and that's a new area we're going into. An area we've seen in society that we have to deal with is harmful algal blooms. And I know you guys are struggling with that in the land of 10,000 lakes. You're not the only ones. This is a big deal. Understanding harmful algal blooms are a critical economic, human, and environmental health concern across the nation. So we're trying to work on developing a network to integrate new and existing monitoring programs to develop early warning systems for harmful algal blooms. We're trying to focus on establishing baseline. What is a baseline bloom or algae? What are those baselines? How do we understand what kicks off a toxic algae bloom and what doesn't? What are the chemical processes? What are the biological processes? So those are the things we're trying to work on. We're just trying to work on setting up this new system. Another big area we're working on in the water quality, water chemistry arena is temperature. So water temperature is a big deal for the ecosystem's health. We feel water temperature is a master variable influencing a lot of different water chemistry. Aquatic health, fisheries, and other processes all depend upon water temperature. One of the things we can do is start tying water temperature to all our stream gauges, adding that variable, master variable, to every place we have a stream gauge. And so we're working on that new area. Another area is not new for us. We've been the pioneers and leaders in environmental tracing and understanding isotopes, but we're going to try to expand that work. We really want to develop a whole new set of environmental tracers and isotopes that we can yield a quantitative information on the water cycle, water quality, and develop new tracers that we can use to understand, identify sources of water, to do water tracing, to help calibrate these integrated numerical models. So this will all take a whole new set of environmental tracers and isotopes. And so that's really the kind of the new work that we're trying to do. We're actually right now testing new tracers and isotopes. We're trying to evaluate them both in the field and in the laboratory. And I think this is going to be an exciting new area of research for us in the future. So that's the U.S. Geological Survey as a whole. I want to drill down my last few minutes and talk about the Water Resources Research Act program that Jeff so kindly introduced to you. That's my program. That's what I manage for the U.S. Geological Survey. That's what I oversee. It is a federal-state partnership. We plan, facilitate, and conduct both applied and basic research. We try to resolve water issues. We promote the transfer of information. This is an example of that very thing, right? Our institutes hold conferences to get the information out to you so that you can use them. The latest research, we facilitate that kind of work. And the other neat thing that we do in this program that's near and dear to my heart, since I'm one of those old gray hair guys, is we train that next generation of scientists and engineers to take our place. And so we build a whole other generation of new scientists and engineers through this program, through the universities. As Jeff said, we are a network of 54 water institutes. We're mostly at land-grant colleges, like the University of Minnesota. Not necessarily all, but we're mostly at land-grant colleges. And there's an institute in every state and territory. So there's really 4 basic elements to this program, and I'll just touch on them just so you know, even though a lot of you are working in the private industry, it doesn't necessarily affect you, but if you are in academia, these are places where you can go to get grants, you can fund students, you can get students, you can work with us on doing both applied and basic research. So we have what is called our annual base grants. Jeff alluded to that. He talked was research it's really research set up to solve state problems. So our annual base grants are for each water institute to dive into the state's issues, develop applied research that will help the state solve whatever issue is eating the state's lunch in water resources at that particular time. So that's really, really important research. We like to think a lot of these are seed grants that lead to much bigger research, but they do the whole thing. We collect data, we interpret data, we provide training of new students, and that's the kind of thing we do with that. We fund around $16 million of that kind of research in this program a year. About 240 projects across the nation, and we're doing everything from harmful algal blooms research to new sensor research to remote sensing research. We do everything in this. We're developing new plastics research to actually get microplastics, new chemical techniques to pull out what kind of contaminants are tied up with microplastics. We fund about 200 students a year in that part of the program. And those are graduate and undergraduate students. We're training them to be the next generation of scientists through their participation in research. So that really is the flagship of the program. We have another program which we call our basic research program, which is to really look at basic research. It's to develop new techniques, new methodologies, new science on regional and national issues. Pretty exciting part of this program. We fund about $2 million worth of that kind of research, about 6 projects or so a year. And really our priority areas are things such as water quality, economics, infrastructure changes, ecosystems from a water quantity and quality perspective. Another part of the program is where other federal agencies can dive in. So this program is pretty exciting in that other federal agencies, if they have a water resources need, they can actually tap into the faculty. So they can tap into the faculty at the University of Minnesota, if you're the Army Corps or EPA, to solve a water resources problem that the agency is dealing with. So we're allowed by Congress to do that, and that's a pretty exciting part of the program. We do about 20, 25 of those kind of projects a year. And the last thing we do, which is pretty exciting, is we have what is called a formal internship program, where we can actually fund interns within the program. And we place about 3 to 4 interns a month across the nation to work on water resources problems. So that's really the last part of the program. What I want to do is share with you, we've set up a new 5-year. So Jeff has he talked about doing a strategic plan. We're doing one too. And we've set up a new 10-year science vision for the program to kind of drive us and guide us for the next 10 years. We want to identify our priority research areas, what our outreach and education strategies are leading into for the next 10 years to look at sustained quantity of quality of water. And so our focus areas in this program, and you'll see they'll overlap with a lot of what you've been talking about. We're going to be looking at water scarcity and availability. That's one of our main focus areas. We wanted to study and understand the drivers and outcomes of water availability. What are the demands? How do we understand? How do we address and sustain human and environmental needs? So that's going to be a big focus area of this program in the next 10 years. We want to look at water-related hazards, floods, other hydrological events, hurricanes, and how they're tied to climate change. That's another big area that we're going to start looking at in this program. We want to look at water policy and planning, social economics. We're allowed to do that with this program, is to look at economics and sociology and how policy and planning and socioeconomics tie and are applied towards comprehensive management of water resources. We're going to look at water quality and human health. That's another new area for us, is really instead of just looking at water quality, we're going to tie the water quality to human health. It's a new area for us and a new place to work. We want to start studying state-of-the-art water technology and innovation. That's going to be another area. We need to start looking at new sensors, new ways of technology, new ways of measuring. Big data. That's the big word out there right now. How do we manage big data? How do we manage and serve the public and you folks in data through the program? And the last thing we're going to do is reinvigorate and build our workforce development and water literacy part of our program. We want to start developing a diverse workforce that's equipped to address the nation's water resources needs. And so those are the things we're going to do. So in summary, the Water Resources Reach Act program, I think, is a very unique research, education, outreach program. I think you've seen some of that with what you've seen here. We respond rapidly to emerging water issues. We can serve and engage locally at the state level. That's what we're doing here. And at the national and regional level, which is pretty unique amongst programs. We can work at the state level, the regional level, and the national level. And that's what makes this program really exciting. We can support the workforce development. We can conduct stakeholder science. We can deal policy. And we can translate all that research and technology through unbiased research to our users. So those are the things that we're going to be doing in the future. We're going to have more of these conferences. You'll see them. We'll be doing more of this. One last thought that I've learned in my career that I want to share with some of the young students here in the audience. I think, when I was in school 30-some years ago, we were really focused on single discipline science. That's really where we were at. I became a groundwater hydrologist. That was what I did, nothing but groundwater. Surface water, water quality, nah. I became a groundwater person. Then we moved to my career, interdisciplinary, multidisciplinary, whatever buzzword you want to use. And people became jack of all trades. So we've kind of gone from one extreme to the next. I want to share with you something that Thomas Hurley, a scientist in the mid-1800s, said, which I think, which I like and I think may help you. He said, try to learn something about everything and everything about something. So I'll leave you with that. Thank you. And I'll take questions.
First question, has the anti-science trend within the current political climate affected the USGS mission? And have changes been positive or negative? Are they sustainable?
Yeah, good question. We're a small agency, science agency, buried in the Department of Interior. And so we really, we've seen a little bit of the anti-science, but we're really funded to do science. Our mission has not changed. In fact, Congress gave us a big increase last year. Even though the administration's cut us, we got a big increase. So we kind of roll with these changes. We've seen these before on the anti-science basis. Kind of roll with the punches. I would say no. A little bit, but it hasn't affected our mission. We're still doing work. You notice I said the word climate change. We ignore all that stuff because we're scientists and believe, we have the basis of science behind us when we talk about climate change, climate variability, whatever you want to talk about, how the climate is changing. The water cycle is changing. We've documented that, and we need to understand that and how to adapt with that. So I would say no with that. They've probably been negative, I guess, after because of the attack on science. There's probably some morale issues for some of the scientists, but most of that just rolls off my back, just like a loon. Water off a loon's back. We still doing science, so yeah, good question.
Very good. Next question. How is the USGS working with NOAA and the National Water Model?
Yeah, another good question. So NOAA, as you know, or some of you know, some of you don't, has built a national water model to actually look at surface water flows across the whole nation. It's part of the National Weather Service. We are working with NOAA. So NOAA's National Water Model really looks at flow. But the USGS can bring to the National Water Model many other parts that NOAA doesn't work in, right? Water quality, part of that modeling. We're actually putting in a water temperature module to the National Water Model. NOAA can't do that kind of work. They don't have geochemical scientists. So those are the things that we can do to help the national model is plug in parts to the National Water Model that NOAA does not have the expertise. And so that's how we're working with them. So water temperature that I talked about is our first foray into the new National Water Model to build that. I think our second one will probably look at stream flow groundwater interactions. Again, we can do that. We have those kinds of modeling techniques. And so, yeah. So we're going to bring in parts to the National Water Model that NOAA does not have the expertise. So it will be truly a combined two federal agencies, not competing on things, but to work to improve a national model. Very good question.
What is the best way to follow and learn about the results of all these great research topics?
Yeah. So one of the things, the new USGS websites, which are still being developed, will have search tools and search engines for one to be able to type in topics, harmful algal blooms, and then come up with the database of research publications, research data that you can tap into. So this is not up yet. It hopefully will be launched sometime around December. this year, and we're actually, I'm working on that myself with our program, is so that you'll be able to get, so you don't have to search by program. What happens now on the USGS websites, you have to know that that work was done in one of those programs that I mentioned. The new website will allow you to not even worry about programs, to be able to search by topics. And that's really going to be exciting so that you all can have need the information for a particular science topic. You don't care what program is funding or doing that. We do, but you don't. And so you'll be able to bypass all that stuff and get right to the heart, which is the data that you need, the raw data, and the science, the interpretation, and the research.
Can you discuss, please, USGS's work on polycyclic aromatic hydrocarbons as a pollutant in water, air, and house dust?
I'm a groundwater numerical model. A modeler. I don't know what that is. No, I really don't know. I can't discuss that because that's not an area I work in.
Go to the USGS website.
Yeah, I'm afraid. Sorry, guys. I'm a numerical modeler.
How can USGS improve the working relationship with states and fellow DOI agencies, Department of Interior agencies, to better incorporate wetland research and inventory programs?
Yeah. Well, yeah. So now you're kind of getting into some of the dirty laundry of the survey. Wetland research is done out of the ecosystems group, mostly through our wetlands research group out of Lafayette. And like many agencies, we're a bit stovepiped. I hate to admit that, but we are. Wetland research within water, we're struggling to try to do that. That's a real struggle for us, is to work across those internal boundaries. We're slowly getting there. But most of the wetland research is done out of the ecosystems group. And they do work very closely with DOI, Fish and Wildlife Service, other land management. That's a tough one. That's about all I really know about that. We don't do a lot of wetland research within the water group that I'm in. I think I'll leave that one at that.
Okay. Does the USGS have cooperative programs or provide grants or technical assistance to NGOs, non-governmental and nonprofit organizations?
No. That's the short answer. By law, all our grants have to go to academic institutes. That's just the way the law was written through our Organic Act. We can work with non-governmental and nonprofit organizations. But we cannot send them federal taxpayer dollars. That's the bottom line.
Great. We have time for maybe one or two more questions. How would you define water literacy, and how do you address the illiterate?
So water literacy to us, in our new vision and where we're going, is that education part, is to help people through this kind of thing understand water terminology, water science. I don't know if you've ever seen, the USGS has a beautiful K through 12 education site. To start working at the K through 12 to educate people in water resources, what the hydrologic cycle is. That's the kind of thing we mean by water literacy and developing of a new workforce. And so that's, it's really through education. We have not done very well in education because we're an agency of scientists. We're not educators. And so I think this is a place where we're going to really rely on the institutes through our academic partners to help us develop water literacy type of programs. Putting out kits so people can go out and educational kits, hands-on kind of thing, using the latest technology and isotopes, that kind of thing. And so we're working on developing that through the institutes, and that's pretty exciting. Yeah. What else we got? Anything?
Yeah, so this will probably be our last question.
Okay.
Did the institutes have flexibility to shift program or research topics for future issues or water contaminants?
Yes, they do. So how it works is the institutes send out an annual RFP within the state. And in that annual RFP, they change priorities year to year. And so a priority, Jeff may write on a priority of future issues or water contaminant. Maybe there's a new contaminant, emerging contaminant that in Minnesota, he can actually write that in his annual RFP. We don't put constraints on that at the national level because it's a state issue. So let's say disinfection byproducts becomes a big issue within the state. He could actually write that we are going to solicit this year research proposals on disinfection byproducts. And so, or look at any kind of future microplastics. That's how Mississippi actually is doing a lot of work in microplastics in the Gulf because they wrote that into their annual RFP. Even though no other state's doing that within the program, they're doing that because that's an important issue to the state of Mississippi. So there's a lot of flexibility in the program to tackle the issues of the state. And I think that's what really makes it a powerful program. Yeah.
Great.
Very fun.
I'll just add to that that's what I see across these 54 water institutes, and we all get together. We're all different, and we're all focusing on different things, responding as we're supposed to, I guess, on the issues in our respective states. But the way, of course, this has evolved, too, is that we have things in common, as I mentioned. So sometimes the priorities in Iowa are not all that different from the priorities here, and then it gives us opportunities to work together. Earl, thank you very much for giving us this perspective. It's great to have a national perspective in this conference, and we appreciate you being here.